Alright, so now let's talk about the regulation of the PDH complex. So, regulation of the PDH complex. Okay, so let's talk about the regulation of the PDH complex. In this PDH complex, we already established that there are 5 coenzymes and 3 apoenzymes. Okay, I didn't tell you the meaning of apoenzyme. Apoenzyme, no, if let me explain something to you. If this is an enzyme, hmm, then imagine this other part to be the remaining part here. I want to paint it red. This part is the coenzyme. Then this other part in white is the apoenzyme. Are you there with me? So the apoenzyme is just the protein part of the enzyme, the proteinous part of the enzyme. So we call the what? What we call the apoenzyme. Why the part that is not protein is the what? Is the it's actually called a cofactor. But if that cofactor now is actually it's an organic molecule, then you call it a coenzyme. So if for example this here is this white part is called what? The apoenzyme, right? Apoenzyme. Well, nobody has problem with this one. This red part here is called a cofactor. Anything that helps the enzyme to function better is called a cofactor. Now a cofactor could either be organic or inorganic. You know, and this apoenzyme here is a protein, Wabi. Is protein, made up of protein. Now this cofactor is non-protein, NP, non-protein. Okay, so the idea is that if this non-proteinous structure, maybe it's also a vitamin like that, I mean it's organic. If it's organic in nature, then we say it is what? It's a coenzyme. We call it what? A coenzyme. So what are coenzymes now? Coenzymes are actually cofactor, meaning they are not protein, but they are still organic molecule. So a good example are those vitamins. We talk about those vitamins B1, all those ones. You get. So this is called a what? A coenzyme. It's called a coenzyme. So please you know this difference. So it's called. It just occurred to me that I didn't explain it in that last video. So it's called a coenzyme. Why? If it's not organic, we just call it an inorganic ion. Like all those your magnesium, you get calcium, you get there are things that are required by certain enzyme to function. Even zinc. Okay, those are inorganic. But once it's organic, we call it a coenzyme. Even this coenzyme itself is further divided. This coenzyme is further divided into two. There are some coenzymes that will always remain with the enzyme, like they can't leave. Those ones are called prosthetic group. They are called what? Prosthetic group. Prosthetic group. They are called prosthetic, meaning they are joined to the enzyme. While there are some that can leave the enzyme, that site in that enzyme. Look at the site here. There are some that will always remain here. They cannot leave. Those ones are called prosthetic group. While there are some that can leave. Those ones that can leave, we call them what? Co-substrates. Co-substrate. Are you there with me? So what is a co-substrate? A co-substrate is actually a coenzyme that can leave that site. What is a prosthetic group? A prosthetic group is actually a coenzyme that cannot leave that site where it is attached to the enzyme. That is the difference. So let's proceed. That's why when we are listing those coenzymes, a good example of a co-substrate is what now? A good example of a co-substrate is what? Is NAD. NAD is a co-substrate in that PDH complex. In that same PDH complex, FAD is a prosthetic group. Are you there with me? FAD is a prosthetic group, like it's acting like a prosthetic group. Yes, both of them are coenzymes. That's why we said 5 coenzymes. We also know that FAD is a processing group. That's why it was not able to leave the chain, but NAD was able to leave and go to the electron transport chain. Alright, so we'll come again to this. In this video, what I wanted to explain before was the regulation of that enzyme. Now, the enzyme is under regulation by both covalent modification alongside with allosteric regulation. So there are two ways in which that enzyme is regulated. We have covalent modification. We have covalent modification. This is the first one I will talk about. This covalent modification basically just talks about phosphorylation reaction. So the enzyme can be phosphorylated. Phosphorylation. So this one is usually under hormonal control most of the time. So think of the hormone that will favor glycolysis or the hormone that will favor breakdown. That is what? Insulin. Is that not so? So what insulin does is that if insulin want to favor this glycolytic pathway or this PDH complex, it usually causes dephosphorylation. So it is going to dephosphorylate the enzyme. Why, if glucagon want to inhibit this pathway, it is going to cause phosphorylation. So glucagon causes phosphorylation, while insulin causes dephosphorylation. Are you understanding my point now? All right. So that is the catch. Glucagon causes phosphorylation and thereby leading to what? Inhibition of the enzyme, while insulin causes dephosphorylation, thereby leading to what? Activation of the enzyme. So that is the catch. So now, at what point is the enzyme actually regulated? Which of those three enzymes is being regulated mostly? Now, the one enzyme that is being regulated is the first one, that enzyme 1. So the enzyme 1 is the one that is being regulated. Remember, the enzyme 1 is having what? As this, what is the cofactor for enzyme 1? CPP, right? CPP. So I mean pyrophosphate. So now, if this TPP is attached, is phosphorylated. So let me use the red now. So let me use on that color and see how it will go. So if this here is phosphorylated with this phosphate, if it's phosphorylated with the phosphate, it becomes inactivated. Now, who actually does this phosphorylation? It's done by what? By glucagon. Are you there with me? Glucagon is what causes the phosphorylation. So, caused by glucagon. Okay? So, glucagon causes the phosphorylation. Now, what will remove the phosphate is insulin. So, if the phosphate is to be removed at all, if that phosphate has to be removed so that this enzyme will become free. Who does it is what? Insulin. Insulin is what does the dephosphorylation. So now we don't longer have the phosphate here again. We just have only the enzyme. So in this case now, let me just put the enzyme will be smiling since it has become dephosphorylated. Good. So who does this reaction? Insulin. Now this one will now become the what? The active enzyme. This is now the active enzyme. Are you there with me? So insulin is responsible for favoring glycolysis because what? It actually favors this dephosphorylation reaction. So the next one now is the allosteric regulation. We'll talk about the covalent. Sorry. We'll talk about the covalent regulation of the enzyme. So the second one we'll not talk about is the allosteric regulation. And in the allosteric regulation, we are using metabolites to regulate it. So allosteric regulation. In the allosteric regulation, basically, we are using metabolite this time. We are not using hormones. So you just think of the metabolite that will favor it. Now you already know that a high energy state we inhibit glycolysis, while low energy state we favor glycolysis. Is that not so? Because why? The reason for glycolysis or this PDH complex is a continuation of glycolysis pathway. The reason for this pathway is to form ATP. Now, if the body already has ATP, which is high energy state, it's going to inhibit this pathway. Is that not so? Meaning a low energy state on the other hand will what? We activate the pathway. So now what are the inhibitors? Shall we just write inhibitors? Inhibitors. I'm not spelling well again. Sorry. So the inhibitors here, they are the high energy state molecule. High energy state. So what are they? Sorry. You have your what? Acetyl-CoA. This acetyl-CoA is the product of the pathway, right? So it's a sign that the cell is energy rich. So it's going to inhibit it. We also have your ATP. ATP is a sign that the cell is energy rich, right? Then we should that in again. We should that sign of energy. Do you know? NAD is also a sign that the cell is energy rich. So this is the popular one we know. ATP, NAD. Then now, since acetyl-CoA is the product of that pathway, of that PDH complex, so it's going to inhibit the complex. Is that not so? Say it was acetyl-CoA that we form at the end of the day now, that we now go to the TCA cycle. So when you form that acetyl-CoA has the ability to what? To inhibit that enzyme. Abi? Yeah. So that is it. The entire PDH complex will inhibit it. Now if you notice now, I'm not specifying which of the coenzyme, which of the apoenzyme is going to inhibit. I just put that it's going to inhibit the PDH complex, okay? But when you are talking about that particular, what is it called now? That particular covalent modification, which is the hormonal one, it is between that one between insulin and glucagon. It is usually the E1, the enzyme 1, pyruvate decarboxylase, that is involved in that one. Now, what are the activators? What are the activators of the? This will be what? Low energy state. Low energy state. So what are the things that are of low energy state? What is the opposite of ATP? ANP, right? Yeah, what should I say? What's the opposite of NADH? NAD, right? Is that not so? So what should I say again? Can you think of as activator? Even the substrate pyruvate, you know it is pyruvate that comes in now. So the substrate pyruvate can also activate it. Just the way the product acetyl-CoA inhibits, the substrate pyruvate can also what? Activate it. So in presence of high pyruvate, that complex will be activated. Okay, so with this now, I've come to the end of this video. In this video, I've been able to explain what coenzyme is, what an apoenzyme is, what co-substrate is, all those stuff. I've explained it, and I've also explained to you the regulation of the PDH complex, how we have the hormonal regulation, also termed as the covalent modification or phosphorylation reaction. You get why I've also explained to you the allosteric one. For the covalent modification or hormonal dependent, that one we talked about how insulin and glucagon were causing phosphorylation and dephosphorylation stuff, trying to activate that first enzyme, which is the pyruvate decarboxylase enzyme. Well, in this one now, I've come down to tell you about the allosteric one, whereby we're using substrate. You get high energy state molecule, we beat low energy state molecule, what we activate it. Alright, so thank you.